Hello. So we are going to continue looking at factorizing. So last lesson we started looking at factorizing expressions. So factorizing is to take out any common factors, which is the opposite of expanding. We talked about how we wanted to focus on different patterns. First, we have a check of are there specific common factors, any obvious ones, and then we try to check, well, if there are 4 terms in our expression, can we do the pair grouping pattern? Or do we have any specific patterns like the difference of 2 squares or difference of cubes, or those special formulas? And today's lesson is to look specifically at if there are 3 terms in our expression. In particular, is it a quadratic, so x squares? We did talk a little bit about factorizing quadratics when we did matrices a month ago. But there are a bit more detailed tricks to look into it, and that's what we're going to look at today. So off we go to page 5, example number 9. So today we're going to look specifically at factorizing quadratic trinomials. So the word trinomials, you think of a tricycle, it has 3 wheels. So a trinomial is something which has 3 terms, 1, 2, 3. In particular, we're interested in quadratics. So these are things where the highest power is x squared. So in particular, we're looking at quadratics of the form ax squared plus bx plus c. So in example 9, we're going to look at the case where we're factorizing monic quadratics, where the coefficient of x squared a is 1. So you have x squared and blah, 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 blah. Later on in example 10, we'll look at a different trick that we need to use when it's not monic, when the coefficient of x squared is not 1. So part A, we're trying to factorize the quadratic because it's x squared, and it's a trinomial because it has 3 terms, x squared plus 7x plus 10. So first on the side, identify your a, b's, and c's. So a is the coefficient of the x squared, so the number in front of the x squared, which in this case is 1. B is the coefficient of x, so the number in front of the x, which is 7. And lastly, c is your constant term, the one with no x's, which in this case is 10. So as we talked about before when we did matrices, I like to do the plus b times ac method. If you read other textbooks or if you follow other teachers, they have their own methods as well. So in my little table method, plus b times ac. So the idea is b is 7, ac, so a times c, ac 1 times 10 is 10. So I'm filling my little table in. So the idea right now is I'm trying to find 2 whole numbers that add to become 7 and multiply to become 10. So the way I think about it is, first think about the factors of 10. So the 2 whole numbers which multiply to be 10, really it's 1 and 10, or 2 and 5, there's no other factors of 10, really. Of these 2 options, which of these would add up to be 7? Well, 1 and 10 add up to be 11, so that's no good. So my only option is 2 and 5. And since I want them to be multiplying to be a positive 10, it needs to be a positive 2 and a positive 5. Or it could be a negative 2 and negative 5. But if they were both negative 2 and negative 5s, then they would not add to be positive 7. Whereas if they're positive 2 and positive 5, then they would add to be 7. So our magic number of interest is a plus 2 and a plus 5. So what that means, when we factorize it, x squared plus 7x plus 10 equals bracket, 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 x plus 2, because that's our first number, and then x plus 5. So we have factorized it. You can check your factorization by expanding your brackets using FOIL. You should get back what you started off with, which is x squared plus 7x plus 10. So similarly, let's do b as well. So x squared plus 2x minus 8. Again, first write down your a, b's, and c's. So a, your coefficient of x squared is 1. B, your coefficient of x is 2. And c, your coefficient, the constant value with no x's is negative 8. Don't forget to take the sign as well. Negative 8. We do our little table. so plus b times ac. B is 2. A times c, 1 times negative 8 is a negative 8. So I'm thinking of two whole numbers that multiply to be negative 8 and add to be positive 2. So again, I tend to start thinking by the factors of 8 first. So 1 times 8 is 8, or 2 times 4 is 8. And you need whole numbers, can't be decimals, can't be fractions. That's all the factors of 8. Now, amongst these combinations, what can you add together to become 2? Well, the difference between 1 and 8 is 7, so that's not possible. 4 and 2 differ by 2, so that sounds good. So let's put a 2 in the first box and a 4 in the second box. Now, this is where we care about the positive and negative signs. We want to multiply to be negative 8, so one of the 2 and one of the 4 is a negative sign, because a positive and a negative multiply to be negative. But we also need the sum to be a positive 2. So if it was a positive 2 and negative 4, yes, they'll be multiplying to be negative 8, but plus 2 minus 4 is a negative 2, which is not the positive 2 which we wanted. So let's switch the signs instead. So we want a minus 2 and a plus 4. So that check, they do multiply to be negative 8, and they do add to become positive 2. So back over here, we're trying to factorize the quadratic x squared plus 2x minus 8. Bracket, 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 bracket. You put an x in front, and then our first number is minus 2, and then my second number is plus 4. Now, does it matter whether I go x minus 2, x plus 4 in that order, or x plus 4, x minus 2, or the order switch around? No, it doesn't matter, because when you expand it, you're still going to get x squared plus 2x minus 8. 2 times 3 is the same as 3 times 2. The order doesn't matter. Right, let's do C. One more, just to be sure we can factorize monic quadratics. So x squared minus 7x plus 10. On the side, label your a, b's, and c's. So a, the coefficient of x squared is 1. B, the coefficient of x is negative 7. Don't forget the sign as well. And C, the constant number is a positive 10. I'm going to draw in my plus b times ac table. B is negative 7. A times C, 1 times 10 is 10. So I'm thinking of two whole numbers that multiply to be 10 and add to be 7. Again, think of the factors of 10, 1 and 10, 2 and 5. What of those two combinations can have a differ of 7 or add to be 7-ish? 2 and 5. So 2 and 5. Now we care about the positive and negative signs. They need to be multiplying to be a positive 10. So it's either plus 2 plus 5 or a negative 2 negative 5, because negative negatives are positive. And the thing to take note of is that we need them to add to be negative 7. If it was positive positive, then they would not add to be negative 7. It will be adding to positive 7. So that's no good. So really, the one we want is a negative 2 and negative 5. So that negative 2 times negative 5 gives me a positive 10, which is what I want. And negative 2 plus negative 5 gives me a negative 7. So back to factorizing, bracket, 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 x, x, first number minus 2 or negative 2, and second number minus 5. Always check your work by expanding your factorization, your brackets. You should get back x squared minus 7x plus 10. So that's monic quadratics, so where the coefficient of your x squared is 1. We do have an extra little trick to think about if we're trying to factorize a non-monic trinomials, quadratic trinomials. So again, we're looking at x squared blahs. Non-monic is when the coefficient of x squared is not equal to 1. So what's the extra little trick in here to do? Well, for starters, let's write down our question, our expression to be factorized. So 2x squared plus 7x plus 3. On the side, label your a, b's, and c's again. So a in this case is 2, because that's the coefficient of x squared. My b is 7, and c is 3, the constant value. It's still the same so far, plus b times ac table. So b is 7, ac 2 times 3 gives me a 6. So again, I'm still thinking of two numbers that multiply to be 6 and add to be 7. So think of the factors of 6 as whole numbers, 1 and 6, 2 and 3. Of these two options, what adds up to 7? Well, 1 and 6 adds to 7. So my two numbers of interest is +1 and +6. So +1 times +6 gives me 6, and 1 plus 6 gives me 7, which is what I wanted. Now, this is where the trick is. So when we factorize monic quadratics, we just said bracket, 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 x, x, and we put the two numbers in. Now the trick is, because we have a non-monic, the coefficient here is 2x squared, right? And for the x squared, rather than just putting the x in the bracket, we have to put in 2x in both brackets. 2 because 2 was our coefficient. And we also have to divide the whole thing by the coefficient of x squared, which is 2. And then we do the same thing. We fill the inside of the bracket with our two magic numbers, +1, +6. Now in your brackets, factorize it out, whatever is possible, because ideally we don't want the denominator. So if we can factorize out a 2, then we can cancel the 2 outs. So 2x plus 1, that cannot be factorized, leave it alone. But the 2 and 6, we have a factor of 2 in common. So let's factorize that out. So we get a 2 bracket x plus 3 all over 2. Thank goodness, the 2 on top and the 2 on bottom cancel each other out. So that 2x squared plus 7x plus 3 factorized is 2x plus 1 times x plus 3. Again, you can check your factorizing by expanding your brackets. You should get back with what you started off with. Let's do one more just to be sure. So b, 10x squared plus 9x minus 9. On the side, write down your a, b's, and c's. So the coefficient of x squared is 10. Your b value, the coefficient of x, is 9. And the constant value is -9. That's c. Do your plus b times ac table. b is 9. 10 times -9 is -90. So you're thinking of two numbers that multiply to be 90 and add to be 9. So factors of 90, you might need a calculator for this one, it's a big number. 1 and 90, 2 and 45, 3 and 30, 5 and, does 90 into 4, don't think it does. 90 divided by 4, no, it's not a whole number. 90 divided by 5 is 18, or 8. 5 and 18 don't add up to be 9, so that's no good. So 90 divided by 6, or 6 and 15. Now that's promising, because 6 and 15 can be combined to be a 9. So let's put down 6 and 15. So because we need to multiply to be a -90, one of the 6 or one of the 15 needs to be a negative number. Which one is it? Well, we need to add to be a +9. So the 15, the bigger number, needs to be positive. And then the smaller number needs to be negative, because 15 minus 6 is +9. Otherwise, 6 minus 15 is -9, and that's no good. So check, -6 times +15 does give me a -90, all good, and -6 plus 15 is a +9, all good. So again, because it is a non-monic, the coefficient is not a pure x, we go bracket, 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 10x in our brackets rather than just an x by itself, because it's non-monic. You divide all by the coefficient of x squared, which is 10. You put in your two magic numbers, -6 plus 15. Again, factorize out what you can in the top bracket so that you're trying to get rid of the denominator. In 10 and 6, what's in common? They're both even, so we can factorize out a 2. So I'm left with 5x minus 3 times, in the second one, 10 and 15, they have a common factor of 5. So I'm left with 2x plus 3 all over the denominator 10. Does the top and bottom cancel? Yes, because 2 times 5 is 10, and that cancels the denominator of 10. We don't want a denominator. So all that's left is 5x minus 3 times 2x plus 3. So we factorize that non-monic quadratic. Again, check by expanding your brackets. See if you get back what you wanted, and start off with. So that's pretty much it for today. I'll write the to-do list on the bottom, and good luck. If there's anything, email me, let me know. So page 4, exercise 1.6, question 1b, I, J, N, O, P, V, question 2, B, C, E, H, I, question 3, B, C, F, H, and J, page 5, exercise 48, question 10, 34, 38, 47, 52, and page 7. Exercise 7.8, question 1, K, M, N, question 2, E, G, M, N, question 3, K, M, P, question 4, J, and question 5, I.